In this video I'm going to show grinding a special tool for a customer here locally, and I thought it might make an interesting video. I'm going to show the programming on this control back here in the beginning of the video. If that doesn't interest you, you can skip towards the end and I show the machining or grinding operation. I ran it dry at the end so you could see what's happening. I can't run this kind of grinding dry and you can't see anything if I run it with the, you know, the flood coolant oil, whatever you want to call it, on there. So if you're not interested in the programming aspect, you can skip towards the end and see that. But you know, the programming is kind of different on this control. Air hose back there, and there's a lot of, you know, I thought it might make an interest. Air hose, people blow air hose, and I thought it might make an interesting video here. So watch the video and let me know what you think. I'm gonna go through starting a program from scratch on this software on the grinder. Here's a drawing of what we're gonna grind. We're just gonna grind this Endmill down here, and it's gonna have a 3-inch long overall shank, and these diameters and these angles and everything. So how do we start this on this software? First we got to start a new tool over here, an end mill. It's going to be a new cylindrical end mill with a flat end. This is what the selection you make. Even though the end in this case is going to be 120 degrees, we can specify that in the settings here. So our cutting edge length, according to this, is going to be 400 thousandths. So we're going to enter 0.4 here. And the external diameter is going to be 0.3145 minus 0 plus 5/10. So we're just going to enter this nominal dimension right now, 0.3145. The core diameter is going to be the middle of the tool. I think 180 thousandths is going to be good here. We'll just see on that. We can make changes to any of this in the as we go here if we need to, when we see the graphics display. No taper, and this is going to be minus 30 degree. Oop, got too many minuses there. Minus 30 degrees. Okay, so that puts our point on there. And tip rotation is not going to be any rotation there. So next, we're going to select the number of flutes. We're going to make this a 4-flute end mill with 2 center cutting flutes. Right hand helix. On this particular tool, because I kind of know what it's going to be used for, they're going to plunge straight in to kind of size a hole and chamfer the bottom. And this 30-degree helix doesn't always work too good for that. I'm going to make it about 15 degrees on that helix angle. And next, material is carbide. In this case, our blank is going to be 3/8 of an inch here. Let's see if I can make this 120 degrees. See, but if you make that 120 degrees, it puts it too far back. So I have found, because this is designed for really to grind a flat tipped end mill, but I'm forcing it to grind an angle, 120 degree included angle on the tip. This software doesn't account for that. I have to actually leave stock when I do the actual grinding on the end of the blank, which you'll see in a second here. So we go next, and this thing is sticking out 1.25 from the collet here, and our collet, I happen to know this is 5.8 inches for all these collets, and we'll say 0.630 for the diameter. This just this just is for the purpose of maybe some interference on the grinding wheels to our collet chuck. This doesn't actually represent the actual shape of the collet, but it's good enough for this purpose. So it's defined all of these shapes for us. We're going to have to make changes to some of this, but we have to select grinding wheels. So for the fluting, I'm going to select that wheel, and we're going to say OK for that wheel. This is all on a grinding wheel pack already that I'm selecting. That's all these wheels are on one arbor already, which you'll see when we get to the grinding process. Okay, so this is the basic settings we have. Now on here I calculated, my writing's not too good, but that's 0.0907 we got to leave on the end of the blank. So for the purpose of this simulation, we're going to leave 100 thousandths on the end of the blank, nothing on the diameter, because we specified our shank and blank diameter is 3/8 of an inch, and this tool is really going to be ground to 314.5 thousandths. So that is actually good enough just to do the initial simulation, which we're gonna see here. Except I don't want the program shape of the blank, so I got to go back here and make this selection instead of the program form, I'm going to select cylindrical here. Okay, so this is our shape. I'm just going to run this simulation. This might not be exactly right to begin with. We're just going to look at it and see what it looks like. Okay, it's not far from what we want. Except I don't like these lands, the width of these lands. According to the drawing here, we need to have a 60-degree taper coming out there on this little spot here. And what else? I think we're gonna also rough off this angle too a little bit, so the grinding wheel isn't taking so much stock right here. It would do it, but this is being ground with the cup wheel, and I don't want to put that much load on that particular tool. I might, looking at this, let's go to this view. I might want to go a little bit smaller with my core diameter too. So let's change that first. Core diameter, I'm going to go to 0.155. Let's try that for that. I'm going to resequence these a little bit because I don't like that. I like to gash the tip before I do all of these reliefs and stuff on that. What else did I say? Oh, we want to decrease I'm going to move the primary clearance last on the grinding, and we're going to decrease the width of this land to 15 thousandths on its land. And also I'm going to reverse these, so I do the OD's primary or cutting edge clearance last, and I'm going to do that at 0.015 as well on the width of that. So we're going to also lead off of these at the 30-degree angle to make our 60-degree chamfer. I'm going to make that about 80 thousandths long because it'll need to be longer because of the angle. And this is about 50 thousandths long at 30. So that might be enough to do this. Let's just see. Let's go back to this so we can see the grinding wheels and everything, the simulation. Okay. Now these clearance angles, because we've changed the angle of the tip of this, to grind an angular. It might rub here when it's going around this, when it's making this chamfer, because the clearance angle here, the secondary clearance angle, really isn't steep enough, and we might have a problem here. So I think we're going to increase that on the tip here. And we're going to change it as we come. We're going to start 16 might be all right there, but as we get up to the center of the tool, I want to go more like about 24 degrees, I think. The land width doesn't matter. This is secondary clearance. It's going to just take care of itself because the primary clearance on the tip. But we're going to also vary this to a little steeper angle right at the tip. And we're going to taper this land down to say 5/1000ths of an inch right at the tip of the tool. So let's see what all that looks like before we get going here too far. Oh, can't see it there. Okay, that looks a little better. You see, with this kind of a tapered tool, tapered tip, you're going to have more clearance as you come down towards the end of the tool, because it gets smaller in diameter and you naturally would need more clearance. So that doesn't look too bad like that. Now we're going to rough off this angle. So there's no automatic programming for, so we got to do insert a manual grinding path. I'm going to select a grinding wheel of this. This is the fluting wheel in that wheel pack. I got to think about how to program this again. Let's see. We're going to be set at minus 30 degrees, I think, here. Let's see how this works. I think it's going to actually be at 30 degrees because we got to change the grinding position of the wheel. Minus 0.25. The minus on the Z, or in this case, is away from the tip of the tool on this. It's kind of reversed. Even though you would think of going minus towards the holding or the chuck or the holding device, but in this case it's reversed. Cross. Okay, we're going to be all right there, and then we're going to go. I'm going to just go to 0 for right now. I'm going to have to go further than that, and we're going to go to 0.3. We're going to have to look at this, and then we got to put one more thing to rotate 360 degrees here. We're going to have to look at it when we're on the graphics to see how it looks, and we got to change the grinding position to the. Well, that's good on the outside. I may have these angles reversed. We're going to see. Yeah, I do. It's going out of the limits in B, so this might have to be minus 30 degrees. See how that looks. I might have the X's backwards too here. We're going to have to see on this. Every time I do this, I get it reversed for some reason. So I'm going to step and look at the whole machine simulation. I'm going to step into this and see where I'm at. Yeah, see, I've got the X's reversed, so I got to reverse it here. Let's stop that. I got to go minus 0.3. Sometimes this gets, if you have to reverse that wheel grinding position, that gets reversed. So I'm going to have to go deeper in Z, but I just want to see that I'm in the right place first of all. I'm going to step over to this, see we're not too bad off. Let's step through it and see. But our chamfer isn't big enough, and also we're doing this at every flute. We only need to do it once. So we got to go over to here and select this division we're doing only one division instead of 4 flutes because we're rotating 360. So we've got to do that. And this, let's go 0.070. We'll try that and see if that works. We'll just run the whole operation here. That might be alright. We'll see. Let's continue. If it cleans up when it grinds the clearance angles, which it did, so that looks pretty good. Now, this first cut of taking this whole big chunk of material off the OD is not really that great for the grinding wheel. We're taking a 16th, roughly a 16th of an inch off this OD, so it's 30 thousandths on each side. And I could probably get away with that in this case, but I'm going to slow this feed rate of that, not the tip clearance, the secondary relief. It says it's going at 7 inches a minute here. I'm going to slow this way down to about 1 inch. I'm going to slow down this finish cut. I don't like to go that fast. It leaves a little bit rough of finishes on the cutting edges if you go this fast. They grind production end mills that way, and that's all right, but and this is a custom tool. I like to leave a little better finish on those features, and I'm gonna slow this fluting down a little bit too. I don't want to put too much force on that. I'm going to leave that alone. In order to run it, we got to go up here to manufacturing. We're going to probe just the overall length. Oh, I got to change a setting here. I'm taking off this adjustment length setting here. It's set in a different place here. Where is it set? Excuse me. Here, this setting here, I have to increase because it won't let me go to the distance I need. It'll tell me I've set it too much if I set it up here to 100 thousandths, we'll say. On here, we're going to probe because now it's set. I can go as much as 120 thousandths. If I go above that, it'll give me an error saying I can't do it unless I set that other setting higher. So I'm going to probe just the length, and that should be good to start here. We've got the right grinding wheel pack in the machine. Oh, I didn't even show that. We've got to make sure on the configuration we have the right grinding wheel pack, which it's this Naxo Endmill, I call it. These grinding wheels are called Naxo grinding wheels on here. So I've got it in the right place. So we can go back here, go back to 100 thousandths here, probe the length, and click manufacturing. Fluting wheel is very close to call it 177 thousandths. That's good. Not going to worry about that. It's far enough away. I'm going to also display the wheel compensation on this OD wheel. I got to hold a close tolerance. So plus, oddly enough, is going smaller on this. I'm going to set this to 2 thousandths. It was on 5. And minus is going larger. I don't know, it's just reversed on this grinding machine. Everything seems to be kind of reversed. So we're ready to go. Now let's see if I can video some of this. It's very hard in this machine, and there's a lot of coolant flowing around. In fact, I'm going to turn the coolant off. See, I get this warning message that the coolant's turned off. Run the probing cycle with the door open here. See if we can do this. So it's probing the length. That's all we need. It can probe the flute division and everything, but I'm not needing that right now, of course. So the first thing it's going to come and do is trim the end of that off like you saw in the graphic. But now I'm going to have to turn the coolant on, close the door, and you're going to see now that very difficult to see anything. I thought I'd run a dry cut so you could see what was happening. And here it's just roughing off that conical end like we saw in the programming. Then I added this cut to take some load off the cup wheel, grinding the clearance angles on the OD. So that you didn't see in the programming, but I added it later. Here's the fluting cuts. Cutting the flutes, each one of the 4 flutes down the OD. A couple of different views of it. Then the gashing of the tip of the tool, the gashing wheel. Come back and grind the secondary clearance on the OD here, the cup wheel. That's why I roughed off a little more stock, so I didn't want to put too much stress on this wheel grinding the secondary clearance angle. And then the primary clearance angle on the OD. Let me come back and grind the tip relief angles. These are full 5-axis moves here to grind this geometry. So that's the secondary clearance angles, the tip, and then this is the start of the primary, and here's the primary clearance angles on the tip. So that's it running dry with no oil on it, just so you could see it, because you wouldn't be able to see anything with the oil. Here's a few views of the finished tool under the microscope. It's very hard to get something clean under the microscope when you photograph it. You got dust and grit and stuff all over it. You got to really work at it to get it clean. So here's a couple other views of the finished tool.